Let's continue from where we left off in the previous video. We said that in the procedure source we will have to differentiate according to the mode. And for this we begin by placing a doCase command for which we will have to program each case, the insert, update, and delete. Let's start with the last one, which is the simplest. If here we have the data of the attraction table, the way to retrieve a record of the table by command was with a for each. What do we want to do with this record? Delete it. To do this, we use the delete command. It is that simple. Updating is also almost obvious. Let's suppose that we have added a new category to the system, landmark, and we want to set that category instead of the one it had. Then we select the for each on the record and simply assign the new value to the attribute we want. With the find aggregate formula, we are asking to browse the table where this attribute is located and to return from the first record found there that meets this condition the value of this attribute. In this way, we will obtain the ID of the landmark category. If that ID is 3, then when this for each is executed, the value 2 will be changed to 3 for this record. And what would happen if a category with this name is not found in the category table? Let's try this to be certain. To go faster, we have already created the procedure and added to the web panel the invocations for update and delete. In the procedure, we have already written what we have been analyzing. Let's run it. First of all, let's add the landmark category. Now let's return to our web panel. And for the attraction 2 that has this category, let's press update. We don't see anything because the procedure was run and completed, and we are not asking it to report anything. But if we refresh the screen with F5, we see that now the category is landmark. Let's set it back to the category it had, historical site, and delete the landmark category. And let's try again. The program has crashed. This is because the find formula will return 0, empty, since it finds no record in this table with the value landmark. So the for each at the end of the iteration will send to the database the order to perform an update of this record, assigning 0 to category ID. But since category ID is a foreign key, if the database allowed a non-existent reference value for this other table, the referential integrity would be violated. The same would have happened if category ID had been 3, 4, 5, 10, anything other than 1 or 2. By default, the database performs the integrity check, and if it fails, it doesn't allow the operation, throwing an exception which, if not handled, interrupts the program as it happened to us. This is very important. CRUD operations performed by command in procedures, which is the only object in which they can be used, do not perform any referential integrity check. This means that they send the order to the DBMS without checking anything. Some might wonder why, when trying to set category ID to 0, the DBMS throws an exception, when in the transaction, since we had set the nullable property, we could leave it empty, without any referential integrity failure. The reason is that empty is a value, 0, and it is not the same as null, which is a non-value. The nullable property indicates that it will accept in the database that this attribute has no value, and it indicates this with null, which is not the same as value 0, because 0 is another value, like 1, 2, 3, 4. That's why, when it is left without a value, null, the integrity is not checked against the category table, because if there is no value, there is no reference. On the other hand, if it's left at 0, there is a value 0, and it will look in the category table if there's a record with ID 0. Because of this property, when we leave the field empty in the transaction screen, it is going to take it as null and not as 0. And for that reason, it doesn't fail. However, this property only indicates what value is assigned to the attribute when the user leaves the field empty on the screen. Null will be assigned. But it doesn't apply to code. Instead, here it is empty because the find returns a value. In this case, 0. And for that reason, the database throws an exception and the program crashes. If in that case we wanted to assign null, we could add this. Asking for isEmpty is the same as asking for is equal to 0. The setNull method assigns null. And in this case, it would work the same as the transaction. On the other hand, and to the same extent, let's ask what will happen if we want to remove the Great Wall attraction, which we know has a tour that is referencing it. If we try to do it through the work with, it will not allow us to delete because the transaction program does check the referential integrity and does not send an order to the DBMS if it knows it is going to fail. It immediately informs us that the deletion is invalid. On the other hand, if we try it through the procedure, it crashes. This could be seen as a disadvantage of update commands, which don't perform referential integrity checks before sending the CRUD order in question. It is up to the developer to perform the check by code before performing the operation and only request it to the DBMS if there is total certainty that it will not fail. The advantage, on the other hand, of not making the checks automatically is efficiency, because checks are time-consuming and sometimes they are not needed. For example, if the entire database is to be deleted, before going to the insertion, what would happen if we modify the name of the attraction to leave it empty? If we do it through the transaction, it doesn't allow us to do so because of the error rule we have declared. On the other hand, if we do it through the procedure, it allows it perfectly. The reason is that the update by procedure with a for each command doesn't take into account at all the business rules defined in the transaction, which is another object. We could also update with the for each not only attributes of the base table record, but also of each of those referenced by the extended table. In this way, we could update the category name attribute of this attraction, the city name and the country name. Now we only have to study the case of creating a new record. That is, inserting a new attraction. This is done using the new command, assigning values to the attributes of the table where we want to insert the record. Since the table only has these attributes, we must assign values to them for the record to be inserted. Category name, country name, and city name do not belong to this table. The new command will ask the DBMS to insert a new record on the table inferred from these attributes. Since attraction ID is auto-numbered, no matter what value is assigned to it, for example 0, the database will ignore it and assign the next number after the last one used, which in this example is 4. Therefore, we could choose not to assign any value in the new, which is the same as leaving it empty. Let's hard code for now the values to be assigned for our new record. For the name, Christ the Redeemer. For the photo, if we have for it an image in the KB with this name, then we make this assignment. Could we leave these 3 attributes that are foreign keys unassigned? As we have been insisting, yes, not only the program will allow it, but it will not make any check, and it will send to the DBMS the order to insert. But, as we already know, by default the DBMS will throw an exception for violating the referential integrity. So, to category ID, let's assign the ID of the category named Historical Site, which we assume exists in the category table. If it finds it, it will assign it to the attribute of the record we will insert. If it doesn't find it, it will assign 0. and we already know what will happen next. Similarly, to country add, we assign the ID of Brazil. Also here, if it doesn't find it, it will assign 0 and we already know what it will end up in. And we will do the same for city ID, assigning it the ID of Rio de Janeiro. Once this entire block of assignments within the new has been executed, the program sends an insert order to the DBMS with all these assignments. If the DBMS can do it, given that the referential integrity doesn't fail, the new record will be inserted in the table. Let's try it in GeneXus. We add the invocation to the procedure, passing the insert mode and 0 for the attraction need. Here we have inserted the image in the KB, and in the procedure we have inserted the code we just analyzed. We are going to launch a run. The navigation list shows a warning related to the commit operation on the database, which we will analyze later. It informs that it will perform a new on attraction. Here, it graphically shows the table used in the new, and the indented ones are those that must be navigated by each inline find formula. Then, it reports about the insert operation that the DBMS will send on the attraction table and the attributes of which it will send values for the insertion. Here it informs about the update. And note that it only sends the value of category id, because it is the only one that we are modifying in the code that we left. In the procedure, finally, we see the report of the delete. Okay, let's execute. We click on Insert, refresh the screen, and here we see the new attraction. To avoid having to manually refresh the screen, let's execute a refresh command as soon as the procedure finishes running, and control returns to the event in the web panel that called it. What will happen if we run the insert again? It will try to add a new attraction, but with the same name as this one we just inserted in the previous step. If we didn't have a unique index for attraction name, that's exactly what would happen. We would end up with 2 attractions named Christ the Redeemer. However, let's try. Nothing happened. That's because CRUD commands don't allow us to catch database exceptions for referential integrity violations, but they do for uniqueness. What actually happens is that the insert command is sent to the DBMS, and the DBMS tries to execute it. However, since it detects that Christ the Redeemer already exists in another record, it blocks the insertion. Unlike what happens with foreign keys, it returns a duplicate key result to the program, allowing some action to be taken in response. The action is taken if the when duplicate clause is programmed in both the new and the for each, so that the developer can code something when such cases occur. This doesn't happen with referential integrity failures. If the when duplicate clause is not coded, then nothing is done. It's as if the new or the for each hadn't been written. To summarize, CRUD commands send the request to the DBMS and only capture the result of the uniqueness control, meaning they detect when as a result of their execution. The operation could not be performed due to a uniqueness violation, either by primary key or by candidate keys, i.e., attributes with unique indexes. In those cases, if no when duplicate clauses are used, nothing happens. In our case, since attraction id is auto-numbered, there can never be a duplicate record due to the primary key. However, if it weren't auto-numbered, then it could. If we try to assign the value 4 to it, there is already a record 4, and it fails. So in that case, a duplicate key can be returned due to the primary key or due to the candidate key, which is that of the attraction name attribute, as we have already seen. To wrap up the essentials, we still need to address the warning that appeared in the navigation list regarding the commit. When we examined the entire process carried out in the transaction object, we saw that a commit was implicitly placed at the end of the instance. The same will happen for any procedure that has a CRUD operation coded in its source. An implicit commit command will be automatically added at the end of all the code. Let's think about this procedure example. We create the category landmark. Update the category of all attractions that had the name historical site to the new one, landmark. And finally, delete the historical site category. So, we are inserting a record in the category table, updating several in the attraction table, and deleting another one from the category table. GNexus will add a commit command at the end of the source code. This means that all these operations on the database, here 4 in total, 1 insert, 2 updates and 1 delete, will be made permanent. This will be the default behavior. We could turn off that commit so that it is not added using the commit on exit property of the procedure. The transaction object also has this property on by default, and that's why the automatic commit is performed, but we can turn it off. But also, whether or not we leave that automatic commit at the end, we can always code and commit explicitly wherever we want. For example, if we place this one here, after inserting this category, executing commit will make it persistent in the database. If the system crashes later, for example, after the for each, these 2 updates will be undone. That is to say, the rollback operation will be performed automatically. But this insert will remain in effect. If the process reaches this point, and the updates were performed and now a commit is executed, those 2 records will also become permanent. Then, if we try this delete, and the database throws a referential integrity exception because some other record in another table references it, the program will fail, but the 3 previous records will remain permanently in the database. If, on the other hand, these 2 commits were not there, then these 3 records will not remain in the tables either. Note that in any case, if we leave the commit on exit, it is not necessary to place an explicit commit here. Lastly, just as we have the commit command, we can also use the rollback command in the code, its inverse, which undoes all operations performed on the database that have not yet been committed. In this video, we studied how to perform create, update, and delete operations through commands in the procedure object. Thus, we use the new command to insert a new record into a table. We saw that the insert order is sent to the DBMS without any checking. To update a record in a table and optionally its related records through the extended table, we use the for each command, directly updating the desired attributes in its body. For each iteration, an update order will be sent to the DBMS without any checking. And to delete a record from a table, we access it with the for each command and use the delete command within it. Again, no checking is performed. However, a uniqueness violation is different from a referential integrity violation. The former is automatically handled by the program, allowing execution to continue. The second one is not. Nevertheless, it is possible to handle the exception within the program. But this must be done explicitly. It is not automatic. This is achieved by using the error handler rule, which was not covered here. Finally, we saw that by default, the procedure adds a commit command at the end, which can be removed. We also saw that commit and rollback commands can be specified explicitly in the source. Here we show a comparison table of the checks that are performed by the transaction, but not by the procedure. In the next video, we will study how to perform these same operations using the business component, which will check referential integrity and uniqueness, and will even execute business rules defined in the transaction from which it is obtained. This will be the recommended approach. Lastly, here we see the difference between interactive and batch update.